Welcome to the tutorial course on GCSE Computer Science, brought to you by Matt at Homeschool Education. I'll be your tutor throughout this course, and as always, if you have any questions, do post them over on our subreddit or in the comments below. One of our core aims at Homeschool Education is to provide answers to questions that students have, so you are guaranteed a response if you ask a question on the subreddit. Please be aware that the subreddit is monitored more than the comments on this video, so keep questions there and not in the comments below wherever possible. What is an algorithm? It is a sequence of steps that can be followed to complete a task. Remember that a computer program is an implementation of an algorithm, and an algorithm is not a computer program. Think of the algorithm being inside the computer program. The program cannot go inside the algorithm. We're going to use making and drinking tea as an example throughout this video. Making tea can be considered an algorithm. A series of instructions are performed in order to complete a task. What is decomposition? Breaking down a problem into multiple smaller problems. For example, in the process of making tea, the process could be split down into fetching ingredients and then mixing them to make the tea. This is an example of decomposition. Think of it like decomposition of an object, where the object is broken down into smaller parts, for example the decomposition of water into hydrogen and oxygen. What is abstraction? Removing unnecessary detail from a problem. For example, when making tea, you could have a biscuit with your tea. However, it is unnecessary. You do not need a biscuit in order to drink some tea, which is our final objective. This is an example of abstraction. Think of the word as it is. The immediate thought from the word abstract is peculiar and unexpected, which you could link back to being away from the norm, which could be linked to being unnecessary. Remember that different algorithms can be used to perform the same function. For example, these two simple algorithms give the same result, t. I'll give you a moment to read through them. In one, we use tea leaves in order to make the tea. In the other, we buy the tea bags. In both algorithms, we reach the same conclusion, drinking the tea. A linear search algorithm is where a target element is located within a data structure, normally an array. Each element is checked to see if it matches the target of the search. If it does not, the process moves to the next element. If it does, the process stops because it has found the target. Before we begin this section, we should define three terms: ascending, descending, and iteration. Ascending is where values get larger as the structure continues, so the array 2, 4, 6 is in ascending order because each value is larger than the last. Descending order is the opposite. Iteration means progressing through all of the values, so iterating by one means moving on to the next value. Here is an example of linear search. In this example array, we have 32 elements sorted in ascending order. We have a target value, that is, a value to locate, of 89. The linear search works by iterating through each element in the array and checking to see if it is the target value. If it is not, then the algorithm moves on to the next element. If it is, the algorithm stops searching because it has found the target. The dark grey square indicates where the algorithm is currently looking. The algorithm has now found the target value, so it stops searching. A binary search algorithm is fairly similar to the linear search algorithm in that it locates a target inside a data structure. However, the binary search algorithm goes about it in a more intelligent way than the linear search algorithm. Say we have this array from the previous example. We're again looking for the number 89. The binary search algorithm will take the middle value, here being 42, and see if the target, 89, is larger than the current value. It is, so the algorithm knows that the target value cannot be smaller than 42, so it can therefore discount all values before and including 42. The process then repeats, cutting the array in half until it reaches the final result. The algorithm has now reached the target value, so it stops searching. To compare the two, linear takes longer than binary because it simply goes along and checks each element in the array until it finds the target, whereas the binary search intelligently slices down the array until it locates the value. The linear search took 30 attempts, whereas the binary search only used 4. A good way to think of it is two people trying to find a person inside a house down a row of homes. One of the men, linear search, starts at the bottom of the road and knocks on each door to ask if the target person is at the house. He then goes down the road, knocking at every door before he finds the target person. However, the second man, binary search, goes to the middle house and asks if the target person is left or right of the house, and continues like this until he finds the person. In this very first step, he can already discount 4 of the 6 houses far quicker than the linear search man could. The merge sort algorithm is quite complex, so I will only do a brief overview. I encourage you to look up videos on merge sort algorithms on YouTube because there are some good examples already up. Say we have this array 8 elements long. It is not sorted in any way, but we want it to be sorted in ascending order. So we split the array down into halves until we are left with the single elements. We then sort into ascending order in gradually increasing groups, and finally combine them back into an array which is sorted in ascending order. The bubble sort algorithm makes multiple passes over an array in order to sort it. Let's take a look at this array, 8 elements long. The algorithm will look at the first 2 elements and check if the second is larger than the first. In this example, 8 is larger than 1, so nothing happens. However, when the algorithm moves on to the second and third elements, 3 is larger than 8, so the elements swap over. This continues along the array until we are left with this. However, we are not finished yet, as 4 is larger than 8 and so is 7, so these swaps take place and we are left with the sorted array. The two algorithms are similar in that they both sort a data structure into a defined order, normally ascending or descending. However, they both execute the task in differing levels of complexity, and they both use different amounts of memory. The bubble sort algorithm has a very low memory requirement because it simply moves along the array and swaps values over, so there is little requirement for storing information. However, the merge sort algorithm needs more memory because it has to store what place each element is currently in as it slices the array down. Thank you for watching this video on GCSE Computer Science. Remember to visit our subreddit to ask questions and get involved with the homeschool education community. Subscribe to the channel to see every new video as it comes out, and I'll see you next time.